Good afternoon, everybody. I welcome you all to session 3 of day 2 of this program. Now I welcome and introduce our eminent speaker, Dr. Mukesh Mohania sir, to this session. Dr. Mukesh Mohania sir is a professor and dean at IIT Delhi. Prior to joining IIT Delhi, he held senior technical and business leadership roles in IBM's research and development labs in India and Australia. His innovations center on information integration, on structured and unstructured data, master data management, AI for database and entity analytics, big data analytics, autonomic computing, blockchain data management, and he also developing complex systems and applications in these areas. Over the course of his career, he has led a succession of successful projects that produced technology and products in use across the industry today, as well as influential and frequently cited technical work and patents. He holds 60 plus granted patents and published 100 plus technical papers in international conferences. IBM recognized him as an IBM Distinguished Engineer in the year 2013 and Master of Inventor during 2010 to 2019. And he is also a member of IBM Academy of Technology in the year 2011. And he awarded with Best of IBM in the year 2013. And he has received several IBM corporate and research level awards. He has held several visible positions like ACM Distinguished Scientist from 2011 to till date, and ASM India Vice President during 2015 to 2017, adjunct professors, Industrial R&D Board at various top universities in India and Australia, and many more, and has received IEEE Meritorious Service Award and ASM Outstanding Service Award. Now I request Mukesh Mohania sir to take over the floor. Thank you, sir.
Thank you very much for the kind introduction, though it was a bit long, but I'm glad to see you all here. Can you give me the permission to present? Can you?
Okay,
yes,
sir.
wonderful,
Okay.
wonderful. Thank you. You can see my screen, right?
Yeah, it's visible, wonderful, sir.
Great. Thank you once again. So let's make this session really interactive. I will really feel very happy, and you will also basically will get or will learn more actually if we interact in the session. And if you have any questions, just speak up. Okay. So what I'm going to basically discuss in this session, the topics he has given me, overview of AI, machine learning, and the blockchain. But I will take basically the perspective of these three technology, how these technologies have been applied in the data analytics. AI, ML, these are the core technology for the data analytics. And data analytics has been basically, we have been doing the data analytics since ages. We are analyzing if then else kind of things. They are very much pertinent today also. And it is a continuous journey basically for analyzing the data to see what is happening in the business. Who is buying, what they are buying, why they are buying, what are they complaining about, how my organization is doing with respect to the other competitors, right? How my products are perceived by the customers, and various kinds of this. And we will look at the data science and the blockchain perspective for the data analytics purpose. Okay. So next I'm going to show you the video, and just listen that carefully, right? And that gives you basically the complete revolution of the industry 4.0 things, right? So let me. All right. So as you saw in this short video, we are in the industry 4.0 era, and how the technology has helped us, the human beings, to evolve over a period of time, right from the machines to the computers. And today's the need for applying the technology is to personalize the things. Like one size does not fit to everyone. Each of us basically have our own sizes. Similarly, each of us basically have our own needs, and how the technology can help to personalize the needs of the human is the need of the hour. And for this, the personalized experience can be provided by analyzing the data. the data about the enterprise, the data about all the transactions, the operations transactions, the data and the about the each individuals, right? The behavior analysis and so on. So this data management or processing has been a journey. Since the relational databases were invented or was invented way back basically early 70s, lot of work has been done for modeling and organizing the data. People started storing the data in siloed systems. Then they realized, hey, we need the data from multiple repositories and we need to analyze the data at the aggregate level. So they started developing the enterprise warehouse. So the, the data warehouses were developed to analyze the data at the aggregate level. But typically in the data warehouse, basically the data was on a structured data, like a transactional or the operational data, analyzing the sales data across the city, across the region, right, across the store wide, maybe by vendor or suppliers and so on. Then they started feeling, hey, we cannot share the data to a centralized place like in the warehouse. Data cannot leave from the enterprise. Can we basically integrate the information in a virtual way where most of the information is structured, but unstructured data can also be used to answer the business queries? So for example, we want to know that the sales of a particular product went down, but we want to know why it went down. Why did it basically did not do well? That means basically that we need to analyze the customers, the client voice of the clients. Basically, they are saying through mails or social media, this or that. We need to analyze that information. And that was the need. Basically, people were doing a lot of work, lot of research, and the systems have been built basically in the late 90s and early 20s. Then there was a need basically that, look, we are getting the data from different kind of channels. It could be IoT devices. It could be basically my operational data systems, transactional systems. It could be the social media tweets and so on. All that information are related, coming from different channels, but we need to correlate that information. So in order to correlate that information, let all the data should come to a single place, which is called the enterprise data lake. Dump the data in a single place, and then start basically discovering the correlation between the data entities. And that is what basically in the late 2000 and early 2010, a lot of work basically are going in this enterprise data lake, and the different database vendors are basically building the products around that. Now lately, due to the heavy usage of the AI, right, we want to basically see that how AI can be used for developing the trusted information, or the information that is coming from different data sources may not be trustworthy. We want to do the trusted data analytics. So then the need for the big data came, right, arised, and then people started building the big data systems, which is basically, I'll tell you more about that, right? And then people started basically building the nice algorithms for analyzing the big data, right? And they call this the autonomous information systems. And using the blockchain technology, where we want to basically, make it completely decentralized network, so that basically, data, the transactions cannot be fudged, and that is what is called the trusted data analytics. And this is the bringing the blockchain technology, using that blockchain technology over the big data, and then developing the trusted data analytics. And that's what the people, all the enterprises are moving to basically develop the AI enabled big data systems to give, to make them more autonomous, and to have that data either on the blockchain or even not on the blockchain. Blockchain is a big hype, and I'll tell you more about that. Is a, right, that using the blockchain or without using the blockchain, how we can build the trusted system, information system, so that the trusted data analytics can be performed on top of it, right? So in order to first understand, let me take basically each of these technology, right, at a very high level, and describe what is a big data, what is AI ML, what is a blockchain, and then we'll take a couple of few applications, right? So big data is so in a relational databases, we were just processing the structured data, right? In what is structured data, like your customer profiles, the transactions, and all other information that has a rigid structure. But since the data is coming from different data channels, and each channel is disseminating different types of data, and at a very fast speed, which is the volume and the velocity, the data is really huge, like unstructured information, like my call data records, which is Bharati or Reliance or Vodafone basically generate terabytes of data in a day. Billions of calls basically are being recorded in a day. Processing these billions of records is a humongous task, and data coming, it is a very high speed, and different types of data is coming, structured, unstructured, text, video, right, my sensor data, and so on. And not all the data is accurate. Some data is in doubt. There may be some noise. So the data which is coming from the sensor might read a incorrect value, right? So before we use that value, we need to really correct it. We need to curate that information. So that is called the veracity of that. Typically, these three dimensions are considered for building a big data, but the veracity is also very, very important dimension. Whether the vendors basically develop this veracity before the data is being ingested in the big data, right? So that is what the veracity is about. How to basically get the data noise free, right? So if you look at these three dimensions, I'm not showing the four because four we can't visualize that. So if you look at the dimensions of volume, veracity, and velocity, there has been lot of work in this area. So there is a machine learning community, or the NLP community, basically they talks about how to process the text data, the unstructured data, right? Little bit of structured data, but they are like Google search is a great example of NLP, right? That they create the inverted index. You can search the data, right? It's a multi petabytes of data. You can search that in microseconds, right? Whereas the distributed systems guys, or distributed systems guys, basically they have done a lot of work basically that how to process the events, right? Distributed events that are coming in a streaming systems. They know basically that how to process the streaming data. Whereas in the database people, they know basically how to process a giga or terabytes of data, structured data, right, which is stored in a relational type of databases. I mean, these days, basically, people are using non-relational databases also to store the structured data, right? So the intersection of all these three is the big data. That is, we have a large volume of data of different varieties coming at a high speed, and processing that information is the big data. So good example is basically is my call records. When we make the call records, as I said, basically billions of calls are recorded every day. Processing those billions of records, though it is a structured data, right? Very little of the unstructured information, but coming at a high velocity, right? That's the big data. So the question is basically is next, why do we need to build a different platform? Can't we basically use the relational databases like DB2 or Oracle or MySQL server to process big data? And the answer is no, because these relational databases, although they are very highly scalable, but they have also their limit. They cannot process, for example, the unstructured data, right? And therefore, we cannot build applications, new applications, like for the cognitive analytics, the risk management, the smarter meter analytics, the geospatial temporal analysis, right? These are the new applications that we need to build on top of the big data. And to build these, we need to have a new capabilities, new features, new functions of that, right? And to build those new capabilities, we need the new technology, right? And that is what is we need to build these data platforms, right, from scratch, and leveraging the relational or existing file systems as much as possible to build this platform, right? So now let's look at basically the journey, as I said, from a data science perspective, right? And what is a data science? A data science is nothing basically is a AI, ML, blockchain, all those technology you bring together and do the advanced data analytics. So let's look at basically what has been done. So the analytics, you can say basically can be divided into the three parts of the building the system, analytics system. One is basically a system of records. System of records means that you have a, let's say, students records, students learning records, and we are analyzing that. Give me all students who have got A grade in database management systems. Give me all students who have got more than 9 GPA and who has completed basically, who are living in this particular hostel. So those kind of analytics can be done using by developing a system of records or basically the relational databases. And these kind of analytics are called the descriptive analytics. And they are built on top of basically my operational internet applications or ERP or online transactions processing systems. But in actual, as I said, we have a lot of other data sources. We have unstructured data sources. We have a data warehouse and online and analytical processing. We have a social and collaboration data, right? So now, second, these descriptive analytics, they have a little, very, very little capability of getting the insights. What is happening, right? You can answer what kind of things, what or who kind of things, but very, very simple kind of who, why this is happening, we cannot answer, right? Now, second level of analytics that one can do to build the predictive analytics capabilities, that we want to predict how many students are going to fail in my subject based on basically, their initial performance and their past results basically of other subjects can be predicted, right? And that is what is the system of insights basically that gives you the predictive analytics capabilities, and next is the prescriptive analytics. And prescriptive analytics is about like when we go to the doctor and when we have a sore throat or and cold, the doctor basically goes not only basically prescribe the medicine for curing the sore throat and the cold, but also basically doctor knows that this will develop a fever 2 days down the road. So then basically to prevent that fever, he basically prescribes some medicine, right? And that is what the prescriptive medicine is, that does kind of complex what if kind of analysis using, right, my ML and the AI algorithm. And the last, where the system would like to engage with the end client, is the cognitive analytics. And great example of that is the chatbot, right? Not a simple chatbot of simple question answer, but basically it's a free format. The system is understanding your needs, your questions, and then basically put the answers based on that. So it's a more interaction through the dialogue on that, right? And for that, we need different kind of technologies. We need to leverage AI and ML heavily to do the predictive, prescriptive, and cognitive analytics. Okay? So how does it work in this? So if you look at the analytics can be done right from the device level, right? The device, what is device? Device is basically creating the data, is basically just streaming the data, right? Now one can basically do the device level analytics, very simple analytics, can go to the gateway, where the gateway basically all these devices are collecting the data. One can do basically the analysis, can basically analyze basically which device is getting more, sending more data, and so on. And then basically all these devices are going to the some fog computing device, and there you can analyze the data at the edge itself, right, without sending into the data to the operational stores or to the cloud. Then this once going to the network, you can do the network analytics on that, going to the cloud, where you can do basically all cloud related, the analytics over there. And then finally you can perform the analytics on top of it. And from this analysis, you derive the knowledge, you bring the contextual information, and then you finally do the cognitive analytics on that, right? That is the complete flow of that. Okay? So in this flow, for deriving the value out of the data, one of the important thing is that how we can convert the data to information, to knowledge, to the decisions, right? And you must have read this in the in the AI, that data is my raw data, which is in the bottom. It's just like a pyramid structure. You have a data, from data, like if I say 1 2 3 4, it is a data, right? We don't know what is the meaning of the 1 2 3 4. But if I say 1 2 3 4 is a roll number of student X, then it becomes an information, right? And from those information, we derive the knowledge, right? From such students, we derive basically the knowledge, and we say basically that students whose roll number is starting from 1 basically gets this kind of things. That is the knowledge basically that we have gathered, or we have discovered over collected piece of information. And once you have derived the knowledge, then you take the decision there. And this is exactly basically that is in the cognitive systems, how the information is flowed from raw data to taking the decision, right? So the data is coming from multiple data sources. We collect all the data from different variety of sources, right? And we collect the information and keep that information for as long as basically that data is required. Now, since the data has a different different types of data, structured, unstructured, semi-structured, and so on. All this data cannot basically model in one way. Therefore, basically, you need a different kind of data repositories to store this information. And then once you have collected the information at different data sources, then you start extracting basically different features and create the metadata repositories. And then you create the linkages between these data entities, right? And this is the data which is a highly of, you can call it as a graph database, where each node represents a data entity, and the relationship between the two nodes represents the relationship between a contextual relationship between the two nodes. So, but two nodes may have basically multiple ages because they might have a multiple relationships. A person A is a friend of person B. A person A is also a mentor of person B. A person A and person B works on the same company, right? So person A and person B has a relationship of multiple types. So analyze this information, learn from this information, understand, learn, and then understanding a region, and then learn from that information, and then basically you adapt that information. That means different people cannot consume the same information. Therefore, we need to basically adapt this information, right? Or different people need to adapt this information the way they can digest that information. So the personalization aspect basically comes over here. So you learn from the user's behavior and interaction patterns to improve the context of that information that you are delivering, right? That is what the information flow in any cognitive systems, right? And this is what basically we use the AI and ML which for right from the data ingestion to the building the knowledge. Okay, now let's basically come to what is a machine learning. So we know the traditional computing. So in the traditional computing, what we do, we give the data, we write the program, and then we get the result, right? This is what the traditional programming is. But in the machine learning, you know what is the output. Okay, so that you already know. So for example, basically you know that a mango is sweet. What are the characteristics of the mangoes, right? And mango is not sweet, or is it bad, or smelly, or whatever, then why it is that, right? So you know that output. So you give the output, then you give the new data. Let basically computers should learn the program, right? And then on new data, you apply the program, you get this one. So if the new mangoes are coming, you have already trained that, then you can basically classify that this mango is bad or good, depending on basically what are the features of the bad and the good mangoes are, right? And that's what the machine learning does, right? Machine learning basically learns the characteristics from the data, makes it a model, and then you apply that model on the new incoming data to classify or to process that data, right? So now look at basically what is the difference in this. So AI is a very broad term. It includes your natural language processing, includes machine learning, it includes computer vision, it includes reasoning, knowledge representations, and so on, robotics, and so on. So AI basically means everything, right? It's a heavily loaded term. But when we come to the machine learning is a very, very focused one. right? So machine learning is a subset of AI where you have a different kind of learning methods, right? You have a supervised method, you have an unsupervised, you have a reinforcement. Since the supervised learning method basically here is you you have a some golden truth, right? And you provide that golden truth as a training data, right? So like for example, again, bad mangoes and good mangoes, right? If you have a some training data that okay, good mangoes are the ones which are really very smoothie, has a this say basically there are no black spots, this and that, and then bank mangoes are there. So you already basically train that data and tag that this is a good mangoes or bad mangoes based on the features that you have chosen, right? That is what the supervised one. So based on the training data, the good training data you have, the better accuracy you will get, better recall and precision that you will get, right? If the training data is bad, then you will get the garbage, right? If the incoming data has not seen any part on the training data, then it also may be the garbage, or you're not sure, then you have to may go and update your training data, right? And then you basically in for the incoming data based on the training data, then you can predict or you can classify or you can do whatever the kind of things that you want to do. But many a times, and indeed most of the times, training data or the golden truth may not be given. Therefore basically we need to apply the unsupervised learning where we don't know a priori, right? Then we use the clustering method, right? Let's put basically all the data which have a same characteristics, right? Put all the data on that, and the reinforcement learning is basically through the experience you apply again and learn that, right? That is what the machine learning is. That and deep learning is one aspect of the machine learning, right? So deep learning again is a subset of the machine learning, right? Whether you take here the neural network and so on, right? So for example, if given an image, we want to see is it a cat or dog or lion or monkey or this that, right? You train the system, right? You give lot of inputs of different images of the animals, and you train basically that this is animal, sorry, this is dog, this is cat, and the systems learn that, right? And that, and then you give new image, then it classifies it is a dog, right? And that. So now what are the different algorithms, right? So in the machine learning, right, as I said, there are typically two types of supervised learning and the unsupervised learning. In the supervised learning, basically you have a two different kind of learning. It's a classification or it is a regression, right? Regression basically like a predicting basically that if the x value is this and y value is this, if you are given x and y values, and now if new x value is given and you'll say calculate the value of y, then first you need to learn that function from x and y, right? Draw the graph and learn that function, and then you can basically plot basically the value of y for given x, right? Or they classify basically like mangoes example that we gave with that. Or you can have a basically the clustering method, given a data points you want to cluster, right? Cluster, and then you can say basically this is all the set of people having a same quality, this is all the people who are having the same quality of that, right? That is the clustering learning method says, and you have a different algorithms basically for classification, regression, and the clustering one. So what is the complete flow? So given a data, right? So you collect the data, various kind of data, right? You basically clean that data, curate that data, and then prepare the data. And remember, as I said, if the garbage in, garbage out. So it is very, very important that whatever the training data that you have for the ML algorithms, or If it is an unsupervised method, the data has to be cleaned. The data should be basically, should not throw any unexpected outcome, right? So you do that, and then depending on basically what method that you choose, right, you train the data and you basically validate that model. And once you have got that, then choose the right method basically to do that, and then basically you do whatever model that you have chosen, whether you want to predict or you want to recommend or you want to detect. Basically you identify those features, right, and develop the applications, right, using those basically the methods that you have chosen. Okay. So now let's take to the application. Before I move to the application, let me see basically if you have any question. Any question? No. Okay, good. So let's take basically a couple of first how the AI and ML will help actually in deriving the insights. So let's say basically we have different kind of databases. We have unstructured information about the people's photo, the passport data, driving license, electoral, water, phone calls, and so on. Our objective here is that given a person name, we want to identify who are the people associated with this guy called Muhammad Yaqub Thapa. Right? We want to identify basically who are the people associated to this person, right? So there is a law and enforcement agency, they want to know, right, because this guy is under investigation. They want to know basically who are the people who hang around with this person, and they want to basically expand the investigation network, right? So they first want to know where does this person live, right? And given these data sources, we have integrated that, and then you can say, oh, this guy is basically lives in the Langata street in Vamana, right? They want to know about this. They want to know more about this. Who is the person associated to this guy? Now, associated to this guy is either this guy is calling to other people or other people are calling to him. That is analyzing the call records. Or basically see basically who are the people living on the same address, right? Or any other logic. So then they say, okay, Bob Smith and Manish Desraj, these are the two people basically, they are related, right? Because this guy is either calling them heavily or they are calling him and so on. Now they want to say, give me more about him. I want to know more about this person. So then they look at this guy, right? They look at basically the passport details and the immigration data, and they find it out, hey, this guy has visited Afghanistan in the last 3 months, and he was seen in a rally also. That they are getting more clue on that. And behind this is all AI-based, machine learning-based algorithms, right? Which gives you basically some confidence, compute the confidence. And so basically, I mean, here in this case, it's easy because we know the Muhammad Thapa, he lives in this address, therefore we know the passport number. Therefore, basically, we know that from the immigration database that he visited the Pakistan. But he was seen in the rally. That is what is the computer vision, right? Deep learning algorithms needs to be applied to identify this person in the video streams. Go there. Now, after knowing all this information, the agency basically would like to put an alert on this guy, right? And they want to know if anything happens around this person, if any other person calls him, or this guy basically goes and visit another country or whatever, anything basically happens around this person, right? then alert the agency, right? And that is what is the tracker is there, right? So tracker basically will look at basically the immigration records, the bank transactions, anything, and anything is happening, they basically will do that. So one example here is an international visitor gave the address as Australia contact, and then basically this guy basically gets the alert of that. Okay, so there are number of basically interesting AI and ML related challenge is about how to collect this information and cleanse all that information and extract the information that is interest to us, right? Which is basically is the how to integrate the multimodal data, because some of them is a structured data, some of it unstructured, some of them basically is a other audio information and so on, right? Now let's take the another example. Okay, I'll take this example. So let's basically this person, Mr. R. Sharma, he has a phone number, this in the mobile phone, landline number is this, right? Satellite TV is this. We want to know, is this the same person? Is this R. Sharma, Rahul K. Sharma, Rahul Kumar Sharma? Is this the same person? Right? So applying AI based information integration techniques, one figure it out. Hey, all these three different Rahuls, they are the same person basically, is right, and we call this is Rahul K. Sharma, right? And on the LinkedIn, this is his one, and on the Twitter, this is the one. Now we want to know who are the people basically who are linked to this person, right? So analyzing the information, we found it out. Hey, R. Sharma is linked to the Prasun Joshis, right? And Ashish Kumar is the business partner of that, right? And all that information is derived from the LinkedIn profile or from basically the call data records, right? And this correlating the information will help in acquisition of the new customer and reducing the churn also. Okay, so now let's get to the blockchain thing. So by now I'm hoping basically you know about the blockchain, but I'll give you a very quick overview of 5 minutes. Okay, so different businesses, they are talking to each other on a one-on-one basis, right? So for example, you buy a new property, a house or shop or anything. You as an individual participant is interacting with the bank for getting the loan, right? Bank basically would like to get some documents to secure basically against which they can give you the loan. So then there are other basically documents, or you go to the bank basically, or go to the third party, get those documents and provide them. You take that property, you buy that property, and then you go and insure that property, right, to insurance company. And also basically you go to the property registration office, you register your house or shop. So in this case, what is happening basically that businesses are talking on one-on-one basis. There's no transparency that this person provided the document to buy the property, how this bank will get the guarantee that the same documents have not been used for buying another property and which are kept in another bank. Basically how the people do fudge the documents, right? So what is the guarantee basically that all these documents provided this guy are the genuine? Number one. Number two, that these documents are not being used by any other entity, right? In India, basically the same agricultural land or house is being sold to more than two people, right? And there is a big scam on that. So to prevent such kind of scam, or to prevent such kind of lack of transparency, there is a need for bringing all these business partners onto the same platform, so that if any transaction happening by one or more than business partners, it is stored at all the places, all the participating nodes, and they can see basically that what is going on the system. So if this guy buys a property, goes to the bank, provides the same documents over here, then this bank can see basically that same documents are not being used by any other bank or by any other entity, and this guy has not taken loan against those papers. That is right. So that means that we have to build a decentralized platform on which the information can be shared by all participating entities for to get the transparency. Second, that if anyone tries to change or modify the transactions, then other parties, basically through the consensus, other party can decide, no, this was not the value, this is the value, right? Because we all basically have the this value, but this guy has other value. That means that guy basically changed that, unless basically all these guys basically, right, they come together and decide and make a union that okay, let's change it, right? And which is not going to happen, right, in the decentralized network, right? So that is what is the blockchain age. A decentralized information sharing platform, where all the nodes in the decentralized network, they don't trust to each other, right? In such situation, right, it is better to use the blockchain technology. And I'll give you basically a small algorithm to check basically whether the blockchain usage of the blockchain makes sense or not, right? Because there is a lot of hype around blockchain, okay? So one aspect of the blockchain is decentralized. So it has its own advantage. We can go 100% decentralized, or we can go 100% centralized. Today's systems are my 100% centralized, right? All the data is owned by one business entity, and therefore can you go on mute, please? Oh. Can you go on mute? Okay. Right. So the systems which are 100% centralized by centralized, database systems, the transaction throughput is very, very good. You can execute hundreds or thousands, or even basically hundreds of thousands of transactions per minute. Whereas the decentralized ones, the transactions throughput is very, very bad. That means that if you have multiple parties and each one basically has the same piece of information, right? And through consensus, when you do that, it takes time. Therefore, the transactions throughput is very bad, right? So we need to find basically for given application whether we should go with 100% decentralization or basically 100% decentralized. a centralized one. And 100% decentralized are called the permissionless, right? It is a public network like a Bitcoin where anyone can go and join the network. You can go and buy the currency, right? Cryptocurrency. So these are the public networks which are the 100% decentralized. The transactions throughput is really bad, though it is improving, but it's still bad, right? Or we can have a permission where the bunch of companies, they come together, like for example the banks are doing the interbank transactions, they come together, right, and they make their own network, right, and it is still basically public ones. Any bank basically can come and join that, and but they need to take the permission from that controlled public network. The other network is basically which are little centralized, is called the permissioned network, right? So all my Hyperledger, Indy or Fabric or all these things, they are the permissioned network, and they are typically are the private nodes, right, where any external node can come and join the network, right? And that is what it's called the private network. So for example, if let's say basically 5 nodes, right, if they are working together and they are doing the business together and they want to come and they want to have a transparency, they will come basically and build their own network there, and called the permissioned network. So any 6th party come, they need to take the permissions to join that network, right? That. So now let's look at basically when do you need a blockchain. So as I said, don't fall into this blockchain usage trap. It's a really, really big hype. There are only certain applications of the blockchain. There are certain applications where you can really use the blockchain technology. And I'll tell you a couple of them, right? So what is the conditions? So first condition is, if you have building an application where multiple parties are involved, first you check, do you really need a database? And if the answer is no, then you don't need a blockchain. Rule it out completely. If the answer is yes, then you see, are many people in these different parties, are they writing on that network? And the answer is yes, or if the answer is no, you don't need a blockchain. If the people are just reading the information, not writing on anything on that network, you don't need. If they are writing the information, then you see, are these multiple parties, do they trust each other? Or is there any one single entity where everyone trusts that person or that node? So if the answer is yes, then you don't need a blockchain. If the answer is no, that is basically that they don't trust to each other, and there is no person, basically there is no person or single entity common where everyone trusts it, then you need a blockchain. Else you don't need a blockchain at all, right? So let me take one example and run it through. So let's say basically a supplier A from India is sending the things to another country. So now multiple parties are there. So when it goes from India, there is a custom. Custom is a one party. Then it's going to the shipping authority. That is another party. That ship is going to the country via another third country. It stops there. Then they have to register what they are carrying there. That is another party. Then that goes to the next country. They need to register what the things have arrived there. Then there is a custom office there, clearance. Then there is a quarantine office there, that what are the things that are allowed, agriculture, this, that, they apply that, there is a office. Then it goes to the wholesaler, to the supplier. So as you see, basically there are multiple parties are there. When things are shipped, there is no trust. How come basically the third party, third country can trust basically that they are sending this item? They have to basically go and check randomly things, right? So there is a lack of trust. So in this supply chain and logistic and the shipping, this is the good use case of the blockchain, where when the things are shipped from the country A, after the clearance, everyone can see what items are going, right? And they can check there, right? And that is what is the blockchain technology. So the blockchain, again, when multiple parties are involved in executing a single transaction. So in my previous example, what is a single transaction? The transaction is sending the item from country A to country B. That is a single item transaction. And multiple parties are there, as you saw. The supplier, the custom, the shipping company, the third party, the destination country, then custom, then quarantine, then and so on. Right? And all of these parties are writing what is in coming to the country and what is going to the country, going out to the country, right? So these parties are updating the database, they are writing the database, right? Or maybe the part of the database, part of the transactions. And there is a lack of trust between these parties. Then you can think of the blockchain. Otherwise, you can do the things without blockchain. So when you are thinking of developing an application using the blockchain technology, first, please go through with this small algorithm. Do you really need a blockchain, or it is a complete waste of time, right? Or is a complete, killing of that technology, right? So the artifacts or the requirements of the blockchain is, number is, the data is written to all the participating nodes. That is, they should have a shared ledger. And what is a ledger? Any transaction is a bhayi khata, right? It's a bhayi khata. Any Sethji is transacting any money, either taking the money from the customer or giving the things to the customer, right, against basically some product or those things. Everything is written on the ledger, and the same transactions is written to all the parties in that network, right? Number one. Number two is, when any transaction, when J is giving 2,000 rupees to Mr. Kishan, this guy J is giving 2,000 rupees to Kishan against buying a product. There is some kind of agreement between J and Kishan, and that is what the smart contract is. That is the agreement between the two entities under which they do the transactions. That is what is the smart contract is. So any transactions that gets executed because there is a contract between the two parties or the multiple parties, right? That is a smart contract. The third is, any data, right, any transactions that is happening, we have to make sure that it is secured and authenticated and verifiable. That is basically that the the transactions hash basically is completely secured, encrypted, authenticated, and later on basically it is verifiable. That. And the fourth and the most important one, all of them are most important, and the fourth is the consensus. That is, anything, if say J transferred 2,000 rupees to the Kisan, and Kisan says no, he never gave me 2,000 rupees, right? You can look at my ledger, right? And in everybody's ledger basically it is written that yes, J basically gave 2,000 rupees, but Kisan basically modified the transactions or the ledger, right? Then through consensus basically one can figure out that hey, Mr. Kisan basically modified the transactions, right? And that is what the consensus is. That through consensus in the distributed process, the network of nodes basically take the decision and they get to agree that this is the transaction value age. Okay, and particularly basically in the private and permission network. Okay, so network ledger we described already this. Okay, so one of the important thing here is that each, what is a ledger? A ledger is nothing basically, it is a blocks, and these blocks are chained, right? And that is why it is called the blockchain. And each block is nothing, it is a set of transactions, right? It is a set of transactions. Like you have a file, right? You store the file in a folder, but each folder has many files, but they are not connected to each other. If you say basically, you can say version 1, version 2, version 3, version 4, but if you delete the version 3, nothing will happen to version 2 and version 4. But in blockchain, this is not the case. The blockchain basically is that first each block is linked to the next block, or actually the next block indeed is linked to the previous block. And how it is linked? That each block has two values. One is the hash value of the previous block and its own hash value. So the question here is, what is this hash value? Where does it come from? How it is computed? And that is the biggest game of computing the hash value. So there are a number of miners. Like what are miners? In the network, you have several nodes. Some of these nodes are the miners. Their job is take these transactions, club together depending on the block size, and then they create the hash value. And once they have created the hash value, they get some reward, right? So the question here is, how do they get the hash value? What is the method? Anyone can do that, right? And the answer is no, anyone can. It requires huge amount of computation, and computing the hash value is not that easy. It is a very, very complex game, right? It's a puzzle. It's a different, it's a, very complicated puzzle. So now the network decides, okay, let's create a hash value that starts with the 4 zeros, right? So then each miner takes these transactions, right? And they start basically with the nonce value. Nonce is value basically, and this nonce value cannot be repeated. It has to be unique. So they take the nonce value 1, take the transaction value, right? Apply the hash function, right? Get the hash value. Does it start with 40? No. Change the nonce value, right? The transactions are fixed. So what is my changing value is only the nonce value, right? Nonce value is changing. Transactions values are fixed, right? Derive the hash values and so on. They keep basically doing this, and whosoever gets basically, the miner says, oh, I got the hash value starting with the 4, then this guy basically sends, okay, these are the transactions, and broadcast that block, the transactions, to every node. And since every node has those transactions, they validate those transactions with the transactions that are there in the block, right? And if they are the same, then they will accept it, else they will reject it, right? And network basically does not reject or accept immediately. It basically waits the others to basically tell that. If the two guys are mining the block and they say, okay, I got the value, right? The two guys said the same thing, right? The network will take that, will not accept it, they validate it, okay. Then they are mining the next block. When they mine the next block, then they say, okay, I've got that value. Then that value basically is linked to that, the other one will get rejected, right? So there are different algorithms basically that who will get accepted, who will get rejected, and so on and so forth, right? So the point basically I'm here is that the hash value is computed from the transactions values and the nonce values, right? And each block has its own unique number. Now you can see if this guy, if this block is linked to the previous block, if this guy basically change one value or one character or one digit, then whole hash value will get changed. When this hash value will get changed, the hash value of the next of block will also be changed, because the previous block it is linked to that is not the same hash value. Therefore all the subsequent blocks will get corrupted, right? And that is why basically is one can figure it out basically who's the one basically whose block basically got corrupted, right? And that is why the network takes the consensus for that. Okay. So now let me take you to the one interesting project that we have been building, is called the truly blockchain application, as called the decentralized education system, right? So today's education systems are highly centralized, that if a student enrolls in an institute, that student will be the property of that institute and has to do more or less all subjects from that institute. Some institute can allow, okay, you can do 2 or 3 or 4 courses from outside, from, we will recognize the course from Coursera or NPTEL or Swayam or some other third parties and so on, right? So highly centralized. Now, that institute where the student is enrolled may not have the teachers, good teachers in all the subjects, right? There may be some ACM Turing Award winner or Nobel laureates in another institute in the same city. But today's system does not basically allow us to go and take the subject from other institute taught by that Nobel laureates or ACM fellow or ACM Turing Award winner and so on, right? So there is no decentralization, number one. Number two is, okay, so NEP, my new education policy, right, allows the two things. One is basically that students can build a credit bank, right? That if the students like basically that I like to do subject A from so and so university, if institute allows, they can go and do that and put that into the credit bank, and then say students completes the 156 credits, irrespective of whether he does from here or there, he's allowed to basically award the degree. The other NEP says that though the students have enrolled for the bachelor degree, but if the student does not like it, either the course or the institute or basically other things, there is no, student doesn't have any options as of today, right? He has to leave without any degree. But NEP says basically that if the students complete certain set of subjects which basically are eligible for getting the certificate, then students should be allowed to get the certificate from that institute or the diploma, right? So now, if you look at this, and if you look at the current education system, right, as I said, student goes and learn in a monotonous way, goes and enroll in the university and gets the employment, right? There is no way basically that if there are many colleges in the same city and the institute is enrolled in this college allows you to go and do the subjects from other institutes. There is no way. I mean, some college allowed to do, like Triple IT Delhi allows basically the students to do 2 subjects either from SWAM or NPTEL or from IIT Delhi, right? Now so if you look at the current gaps, is what I told you is a lack of equal opportunities. Not everyone can go basically to the great institutes. Not everyone basically has, all the teachers and all the skilled in the same university. Not all the basically institute have the quality labs, and the quality of teachers. And basically there is a lack of digitization, right? Not all the university basically provides you the e-degree of that. So considering these gaps of the current system, how the blockchain can help to achieve the basically the NEP objectives. Okay. So let me take basically one simple analogy. So the analogy is the following, that our objective is, right, your family objective is to make a great tasty pizza. That is the objective. To prepare the pizza, we need a lot of ingredients. We should know the recipe how to prepare a great pizza. And to make that great pizza and to serve to the family members, some of the family members have the dietary budget. No, some might have a high cholesterol, therefore they cannot have the too much cheese. And also the family has a budget to spend, let's say, 500 rupees to make the pizzas for the whole family members. So the point I'm saying is there is a constraint, right? So it is just like, is a student objective is to get a degree in computer science. To get that degree, the student has to complete so many courses and labs, right? And to doing these each course, he has to learn in a particular way. That is what the ingredients is. So objective pizza is my degree, ingredients my courses, and the constraints are that this guy wants to do the best course from the best of the college, where is the real teacher, the skills are there. Or he has basically the constraints that he cannot pay the fees of more than 50,000 rupees in a year, right? Because again, different pizza, if you want to make it, ingredients, you have all kinds of ingredients. Maybe the cheese by itself, right, or the pizza sauce may cost 500 rupees, right? So a house member goes to the supermarket and buy these ingredients. When this guy goes to the supermarket and say, okay, I have a pizza sauce which is from 10 different brands, varying from 300 rupees to 75 rupees. So much variation. So the family members will choose the pizza sauce that is within the limit of the budget. That means if a student wants to do a degree in computer science, And in that computer science, let's say there is a course on DBMS, and that DBMS is offered by many different institutes in the same city. There is a University of Madras, there is a Anna College, there is a IIT Delhi, there is a Triple IT, IIT Madras, right? There is a Triple IT Madras. There are so many other institutes, and DBMS is running on those ones. Depending on my budget, which fee is less, or my budget is, there is no budget, but I want to choose the one basically that has got the best teacher, or basically close to my hometown or whatever, right? Will choose that subject from there, right? So you pick up the things, put it in the trolley, go to your home, and you start making the pizza. Some pizza are good, some pizza are not good, right? And you deliver it, that pizza. Same analogy we basically apply here in the proposed model. So what is a proposed model is, you first create a consortium, a network. Same example of pizza, a consortium means basically is these are the 5 companies which are selling the ingredients of pizza, right? So consortium here is a set of institutes or universities or colleges which are offering those courses required for the computer science. And these consortium decides that what are the courses that should have in the BTech in computer science. Okay, so that is what they create the curriculum. They define a common subjects course curriculum across various courses, right? And these courses may be approved by the AICTE or similar consortium body. Okay, so that is what the first part is. So here is to make the pizza, right? These are the 5 companies we will consider for buying the for buying the ingredients, right? Now once the consortium is built, the next step is define the criteria. That is, to make the good pizza, we need to define what is a good pizza means, right? So this says that if the student, once the student has enrolled in a degree, then to get a BTech in computer science, this student should do, let's say, 150 credits. Out of 150, every institute define their own criteria. So let's say the IIT Chennai says basically out of 150, 120 credits needs to be done at IIT. 20 can be done from any other institute in that channel. And 10 credits students can do from anywhere, right? As long as basically he goes and gives, basically we will take the assessment of that one, right? So that is what define the evaluation. If the student does not like or finding very hard at IIT Chennai, he can move to basically the Anna University, as long as basically he or she meets the criteria of the Anna University, right? So this one is to maintain the institute autonomy, right? So each institute defines their own criteria for admitting the students. They define their own criteria for evaluating and assessing the students. They define their own criteria for awarding the degrees and so on, right? So that is what this is the job of the consortium and the each institute. Now a student comes, look at basically that, okay, these are my credentials, where am I eligible to get the admission. So there is a portal that we have developed. Students basically inputs his or her 12th and 10th or whatever the marks are there, and based on basically their admission criteria will tell basically you are eligible to get the computer science admission in institute A, D, and E, right? And that is what basically does. So students enrolls in that one, and then basically he starts basically doing the subjects as per as the institute criteria. Now at some point of time the student is not interested to pursue his or her degree further, then he or she can walk away with the certificate or diploma as long as basically he satisfies the criteria. Or he wants to basically transfer the enrollment from one institute, from the current institute to another institute because of whatever the reasons are, right? And if that other institute criteria, if he satisfies the criteria, then he can transfer those credits and can start basically resuming his or her degree without wasting any time, right? And that is what this decentralized education system or skill chain provides that. And once he completes this, then the degree is awarded to that student. So as you can see, basically that student is flexible to move around. His or her learning records are stored basically in the network, right? To award a degree, basically all the people, all the network one, wherever he has done the course, they have to agree and transfer the credits, and therefore basically the completely decentralized education systems partly basically fulfill the NEP requirements, right? And this is the system we are more or less basically ready, right? We have built that system, right, on that, right? And here we are providing the AI layer for, so students can come and can say, okay, what next course that I need to take, or what skills gap I have with respect to basically the requirements of the job providers, right? So this network basically also analyzes those queries and can do the skill gap analysis and the recommendations one. And in the next phase, we are building basically the AI based layer for matching the jobs and his learning skills, right? On that. And basically we are also bringing to the other nodes like bank portal and other things so that he or she is basically can apply for education loan and so on, right? So with this I will stop here. Let's see basically if you have any question, right? I have few slides and these slides will be distributed to you, but I'll stop here and see basically if you have any question. Okay, any question from anyone? No?
Any questions from participant side?
Yeah. Sir, what type of database is used in blockchain for the transactions?
Right. So you can have any types of data sources. If you have a relational databases, fine. If you have a NoSQL, fine. If you have a file systems, is fine. So there is no limitations basically of you have a connectors, right, that connects to basically any data sources, right? So current basically the Hyperledger, Fabric, or anything, they can connect to any relational or non-relational databases. Good question. Okay, any other question?
Participants, if there any query, please type in the chat box. Sir will answer your questions.
Okay. So
Okay,
if
sir.
you don't have any, right, if you don't have any questions, thank you very much. It's so nice interacting with you, and thank you very much for inviting me here.
Okay, sir.
Right, thank
So
you.
this is a feedback session. Is there any feedback from participant side?
Good afternoon, ma'am. This is Raghunathan from Congo Engineering College. First of all, Professor, thank you. It was a good informative session in the afternoon. Okay, we enjoyed the session. So your examples are so simple and easy for us to connect with. That is how blockchain technology is used in business transactions. Also, it is clearly understood that how BCT is going to associate with ML and AI. So thank you, Professor. Thank you for your session. We enjoyed the session. Thank you, sir.
Thank
Good
you very
evening,
much,
sir.
sir. Yeah, go ahead, Kavita ji.
Good afternoon, sir.
Good afternoon, Mageshi. Yes, go ahead.
I am Magesh from CAC department, Institute of Road and Transport Technology. Actually, this session was very useful and informative. Actually, the way in which the decentralization and DJI examples and usage of AI for this blockchain technology all are very useful. Thanks for your nice presentation. Thank you, sir.
Welcome. Thank you.
Thank you, sir, for your wonderful and informative session. We have acquired knowledge about how machine learning and artificial intelligence impacts blockchain technology, AI-enabled blockchain technology, and also you have given the details about simplified data structure of blockchain and the requirements for blockchain for business and about decentralized education system. Now we are currently writing the exam under Swayam Central, sir. So actually, that is the one application of decentralized education system. So we have gained a lot of information from you, sir. Thank you, sir, for your wonderful session. Thank you, sir.
Thank you so much. And once again, great to see you all, and have a nice day and rest of the FDP program. Thank you. Bye-bye.
Thank you, sir. Thank you, sir.
Bye.
Now I request the participant to give feedback about the, sorry. Well, we have come to the end of the session 3. Now I request all the participants to fill and submit the attendance and feedback form for today's session 3, which will be posted in the chat box. Now you may leave the session and join the session tomorrow by 9 a.m. shortly. Thank you all. Now you may leave the session. I will post the feedback and attendance link in the chat box. Kavita ma'am, is there any feedback from your side?
Ma'am, really the session is very informative, ma'am. Sir has explained everything with pictorial representation. So I thought of giving my feedback when sir was there, but it's okay, ma'am. Anyhow, all the sessions are very nice. Thank you,
Okay.
ma'am. Thank you for
Okay, ma'am.
organizing a very good FDP regarding the blockchain, the role of blockchain. Okay, ma'am. Thank you, ma'am.
Okay, thank you, ma'am. Thank you.
இது இருக்குல்ல மார்க்கெட் இருந்துச்சு ஏறாது போது நம்மளும் தள்ளி விடுறேன் பண்ணாங்க